Hello, hello, hello. So the holy month is coming to its end, and so is this term of the academic year 21-22, which was a long, long, long one. Okay, and I'm going to solve two questions today about circle theorem from worksheet 28, where we called it like mixed questions. So all the skills of circle theorem uh, should um, should be occurred in such questions. So I like to start answering any question by looking at the shape that is provided in the question. And before I start reading which angles they're asking for in particular, I would like to find that first as many angles as I can just by looking at the shape. So as for myself, I would look here. We have three parallel lines and one line is given at the parallel lines, which is 68. So what I can think of is parallel line going through the line that is crossing both parallel lines. And on the parallel line again, can you see the Z here? So this angle, which we can name BCO or OCB, is equal to 68 degrees. Let me write it inside. Because alternate or Z angles are equal. So as I'm answering, in order not to forget anything, I like to write my steps. So I will call it 1, okay? Alternate angles are equal. Accordingly, angle CBD is equal to angle BCO, and both are equal to 68 degrees. So this is the first one. All right, let me erase this here. Okay. And if I want to think of another thing that I can think of just by looking at the shape, I would be thinking of if this is a parallel line, this is the line that is crossing both, parallel line once again. Can you see this angle here? It's a co-interior angle. It's a co-interior angle, and co-interior angles add up to 180 degrees. So 180 minus the known angle, which is 68, the answer will be 112. So this angle here is 112 degrees. So step number 2, co-interiors add up to 180 degrees. Accordingly, angle, we can call it BCE is equal to 180 minus 68, and it's equal to 112 degrees. Perfect. Okay. And by looking at the shape, can you see that BOA is the diameter of the circle? Accordingly, the circumference angle that is opposing the diameter or facing the diameter is always equal to 90 degrees. So this angle here is 90. And as I told you earlier, always write the steps as you're solving so that you don't forget what you've done to solve each angle or to find each angle. So we're going to say that circumference angle opposing the diameter of the circle is equal to 90 degrees. Accordingly, angle ACB is equal to 90 degrees. So we can find accordingly this very small angle here, and it will be 90 minus 68, which is 22 degrees. Okay, so we can write the fourth step here. Angle, we can call it as ACO is equal to 90 minus 68, which is equal to 22 degrees. Okay. All right. What else can we find by looking at the shape? Okay. We can think of from O to C, it's a radius from the center to the circumference. From O to A, this is another radius from the center to the circumference. And the two radiuses are forming triangle AOC, which is an isosceles. So if this is 22, then this small angle here is 22 as well. And this big angle here, it will be 22 plus 22, which is 44. We subtract it from 180, so it will be 136 degrees. Okay? Because angles in a triangle add up to 180. So 22 plus 22 plus 136, it's equal to 180 degrees. Let's write what we've done. So step number 5, we're going to say isosceles triangle, and you must name it, of course, AOC. We found the first angle, angle CAO is equal to angle ACO, which is equal to 22 degrees. And another angle that we found, we said angle AOC is equal to 180 minus 22 plus 22, and this will come down to 136 degrees. Accordingly, we can find this small angle here, So let me first erase this. Okay. All right. So we can find this angle. You can see that this is a straight line, and you can see the 136. So we can find this angle here, which is angle on a straight line. So 180 minus 136, it will be 44. So this small angle here is 44 degrees. So step number 6, we can say that angles on a straight line add up to 180. And accordingly, angle BOC is equal to 180 minus 136 degrees, and this is equal to 44 degrees. Okay, and if we look again from O to B, this is a radius from the center to the circumference of the circle. From O to C, this is a radius from the center to the circumference, which makes triangle BOC as an isosceles. So we're going to say, and accordingly, this angle is 68 degrees. This angle. So step number 7, isosceles triangle named BOC. We're going to say that angle OBC or CBO is equal to angle BCO, and they're both equal to 68 degrees. Okay. One more angle that we can find. Let's have a look now. Let's clean here. Okay. If you look, one more angle that we can find, parallel line. You go throughout the diameter until you hit the other parallel line. So as you can see here, we have a co-interior angle, right? So all this angle, which is 68 plus 68, is equal to 136 degrees, 136, okay? And accordingly, 136 minus, or sorry, 180 minus 36 minus 136, it's 44 degrees. So if this is 44, then this small angle here is 44 minus 22, so it's 22 degrees. Okay? And I think we found all angles. So one last thing that we want to write about, we're going to say co-interiors add up to 180, and accordingly, angle DBA or ABD, angle ABD plus angle BAF, so plus angle BAF is equal to 180 degrees. And angle ABD is equal to 136 degrees. So angle BAF is equal to 44 degrees. And last thing, so angle CAF, the small angle, is equal to 44 minus 20, sorry, minus 22. And this angle will come down to 22 degrees. So I think we found all angles. Okay. And now we can start answering the questions. So they want you to find angle BOC. BOC. Let's go up there. Where is angle BOC? Let me, just so that everything is clear. So sorry. BOC. So the angle is 44 degrees. So angle BOC it's 44 degrees. And where is the solution for it? So that we don't repeat ourselves. As you can see, it's in 5, 6. Sorry, in step number 5. So you can just, I don't know how you can just okay, and then angle ACE. Okay, let's see, angle ACE, which is big angle here. So this one, you can calculate it. As you can see, this angle here is 112. This angle here is 68. And the small one is 22. So which bring this angle here down to, if you say 112 plus 68 plus 22, the total is 202. You subtract it from 360 because angles at a point add up to 360. So this angle is 158 degrees. 158 degrees. So you write here 158 degrees, and the explanation, so you can say 112 plus 68 plus 22. We can all subtract it from 360 degrees to get the 158. Okay, because angles at a point add up to 360 degrees. Yep, and we finished this question. Let's move to the next question. And as we always do, just look at the shape first, and then you start answering the questions that is related to this shape. So by looking at this shape, I will be thinking of, at first, or mostly, of the circle theorem. So, okay, so I would be thinking of arc BC, and you can see that the circumference angle opposing to this arc, as well as the circumference angle opposing the exact same arc, are equal. So we're going to say, so x is equal to 22 degrees. So step number 1, we're going to say circumference angles opposing arc BC are equal. Accordingly, angle BEC is equal to angle BAC, and they're both equal to 22 degrees. Let's erase this. Okay. One more thing I would like to think of. I would like to think of this arc here, CD, and angle CAD. So step number 2, circumference angles opposing arc CD are equal. So accordingly, the angle CAD is equal to angle CED. D, which means angle W is equal to angle Y. Okay? All right. Let's read the question. Sometimes it helps. AD is the diameter. Okay, let's see where is AD and how does that might help us. So AD is the diameter of the circle. So it's passing through the center of the circle, right? From the circumference to the circumference, passing through the center of the circle. All right, if you look at this, and so this is the diameter. If you look at A, angle ACD, which is a triangle right now, right? But this angle that is facing or opposite to the diameter is always equal to 90 degrees. So this angle here is 90 degrees. So step number 3, we can say that angle opposing let me write it in another way, okay? The angle, sorry about that. So the circumference angle that is opposite to diameter AD is equal to 90 degrees. Accordingly, angle ACD is equal to 90 degrees. Okay. We can use this piece of info as well. We can say step number 4, right angled triangle, and always name it. It's ACD. We know the 60 and the 90, so we can find W, right? So we can say W is equal to 180 minus 60 plus 90. And this will bring so this angle is equal to 30 degrees. Okay. So if we find W, we can immediately find Y is also equal to 30 degrees. Okay, so what else can we find? Uh, we can think of we have we forgot all about the parallel lines. So can you have a look here? Parallel line going throughout the line that is passing through the two parallel lines and until I hit the second parallel line. So Z is equal to all this angle, right? So all this angle is 52 degrees, right? 30 plus 22. So this and alternate angles are equal. So this angle is also 52 degrees. So step number 5, alternate angles are equal and accordingly Z is equal to 52 degrees. So I think that we found W, we found Y, we found Z. What else? And we found X, right? So here we didn't write it, but we have to write it, right? So B, B, E, C, which is X. So here X is equal to 22 degrees. So I think we answered them all. So W and Y are equal to 30. So this is 30 and this is 30 and X is 22 degrees while Z is 52 degrees. Yep, and that's it. Those two questions were really very good and they involved many of the circle theorem rules as well as parallel lines and all the rules of finding missing angles that you've learned throughout the year. So I highly recommend that you watch this record as many times as you need to. And yeah, thank you so much for watching, and I will see you in the next record sometime soon. Bye bye.